Hello guys, this is CodeNCode and this is video tutorial for the problem rotation matching taken from Codeforces div 2 round 648C. The problem is basically to implement the algorithm that we have seen to count the cost of ith cyclic shift. So this is just to implement and show you how those concepts that we have learned are used in problems. So that is why we are solving this problem. This is an easy problem, and if you haven't watched the videos, you can go to basic algorithm series playlist on my YouTube channel, and then you can watch first how we calculate the cost of the ith cyclic shift, and then you can come here and then continue watching this lecture. So basically we are given two arrays of length n, a and b, and we have to count the total number of matchings, and matchings are where if there is a matching if I is equals to j, basically on the same index, if there are same elements, then this is called a matching. So at max the maximum matching can be of n elements, so we have to maximize the matching. And to maximize the matching, what you can do, you can shift the either array A or B in any direction, left or right cyclic shift. You can perform whatever shift you want. So you can perform single right cyclic shift as well as left cyclic shift, whatever you want. So this is the operation that you can perform, either perform left cyclic shift or right cyclic shift, and we have to maximize the total number of matching. So it would be more clear if I explain this with an example. So this is example test case. So array A is 1 2 3 4 5. Yeah, the important thing here is that array A and B are actually permutation of n. So all of the element would be from 1 to n. So n is equals to 5, so all of the element will be from 1 to 5. So as you can see, in array A as well as in array B, all of the elements are just permutation of n. Now the array A is 1 2 3 4 5, while array B is 2 3 4 5 1. So what you can do, as it shows, the maximum matching we can obtain is of 5. Now currently we have, I guess, 0 matching. Element at index 1 doesn't match, at index 2 doesn't match, at index 3 doesn't match, 4 and 5 nothing matches. But to obtain a matching of 5, what you can do, you can right shift the array B one time. If you right shift array B one time, it would be 1 2 3 4 5, and as we can see, we are having maximum matching which is of 5. That is why we are printing 5. This is the maximum matching you can obtain. Now in the second example test case, we have 1 3 2 4 in as array A. It is not necessary that you only left shift or right shift only array B. You can also left shift or right shift array A as well, but it doesn't matter actually. Just keep the array A as it is and perform left or right shift on array B. It doesn't matter. So in the second test case, as we can see, array A is 1 3 2 4 and array B is 4 2 3 1. Now the maximum matching is of 2. Currently we are having, I guess, 0 matching. So what we can do, we can perform, I guess, we have performed one right cyclic shift. If you perform one right cyclic shift on array B, it would be 1 4 2 3, and we can see we are having 2 matchings. 1 is matching with 1 and 2 is matching with 2. So the overall maximum matching we are able to obtain is 2. Now to count the maximum matching, what you can do each time, since array is of length n, so there are n rotation you can perform. N plus 1th rotation is same as the first rotation, so there is no need to perform more than that rotation. So what you can do, you can perform one by one, you can perform rotation and then check in ith rotation how many matchings are there. Let me explain you with an example. So suppose this was the input 1 5 2 4 3 and B is 5 4 2 1 3. So these are the things you can do. After 0 rotation means array B is not rotated at all. We'll be going for only right rotation, because right, and if you after performing all of the right rotations, if you are going to check for the left rotation as well, those are only redundant, because for every right rotation there exists a left rotation, so which is identical to that right rotation. So if you have checked for all right rotation, you don't have to check for the left rotation, so we'll be only going for the right rotations of B. You don't have to rotate A at all. So since n is equals to 5, so 5 rotation exists there. 0 1 2 3 sorry, this is not 5, this is 4th. So 0 1 2 3 and 4, there are only 5 rotations, 0 to 4. If you go for the fifth rotation, rotation will be same as the 0th rotation, and all of this I have explained in detail in the basic algorithm series, in which we were studying how to calculate IA cyclic shift, cost of the IA cyclic shift. So if you haven't watched those videos, just make sure you watch those first and then continue here. Now here array B is rotated 0 times, which means array B is same as it was earlier. So we can see we are having two matchings here. 2 is matching with 2, 3 is matching with 3, so we are having two matchings. Now after one rotation means one right cyclic rotation. So right cyclic rotation, after performing one right cyclic rotation, array B, which was originally this, would become this. Now if you see, there is only one matching, which is 5 matches with 5, so matching is 1. Now perform one extra right rotation, so overall there it results into 2 right rotations. So here we can see we are having again 2 matchings. 1 is matching with 1, 4 is matching with 4. What we can do, we can again perform right cyclic shift. So after 3 right cyclic shift or 3 rotations, we are having 0 matchings, because none of the elements matches with each other, so 0 matching. And we can perform right cyclic shift one more time, and then we can see there are again 0 matching. So the maximum matching we are able to obtain is 2. Now if you want to right shift this array again, you will end up getting the same array. So if n is equals to, so if input is equals to n, then there exists n rotations, and for each rotation you can check how many matchings we have. Out of all of the matchings, you can count the maximum, and then you can print the result. But the problem with this approach is that you have to perform n rotations. Each rotation takes big of n time, so to perform n rotations, the overall cost would be n square, and by the given constraint, of course, you are going to get TLE. So if you are coming from those lectures, which I have already told you to go and watch those first, then you already know how to solve this problem. I mean, how to at least think in terms of that solution, and how to convert this n square algorithm to big of n or linear time algorithm. How we are going to do that? See what is happening here. In this case, for each rotation, we are going and performing that rotation and then counting the total number of matchings. While in a better way, what you can do, this is array A, this is array B. For each element, you can determine on which rotation this is going to be on its correct position. So we are only talking about the right rotation. So element 5 would be on its correct position in one rotation. See, if you perform one right cyclic rotation, 5 would come from here to here, which means on its correct position. That means after one rotation, it will be on its correct position. So 5 will be on its correct position on the first right cyclic rotation. 4 would be on its correct position after 2 rotations, right? 2 would be on its correct position after 0 rotation. 1 would be on its correct position after 2 rotations. In one rotation, 1 would be here. In second rotation, 1 would be here. So in and 3 is on its correct position after 0 rotations. So now that we have this information, you know, 2 elements will be on their correct position after 0 rotation and 2 rotation. Frequency of 2 is 2, which means there are 2 elements which will be on their correct position after 2 rotations, right? 4 and 1 will be on their correct position after 2 rotations. Similarly, after 0 rotation there are 2 elements which will be on their correct position after 0 rotations, which are 2 and 3. So the maximum is 2, maximum frequency of each of any element is 2, so the answer is 2, because after performing that many rotation we are having 2 elements on their correct position, so maximum matching you can obtain is 2. So see, if for each element we can count the number of cyclic shift on which it will be on its correct position, we are able to calculate the maximum matching, and this you can do in linear time. For each element you can calculate the number of cyclic rotation on which after which it will be on its correct position in constant time. So for this element you can calculate it constant time, so for n elements the overall cost is going to be big O of n. So if I show you the relation between this and this, you see after 0 rotation we had 2 matchings, and as you can see the frequency of 0 is 2, which shows that after 0 rotation 2 elements will be on their correct position. Basically after 2 rotations the matching would be 2. Similarly after 1 rotation matching is 1. As you can see frequency of 1 is 1, which means after 1 rotation only 1 element will be on its correct position. Here after 2 rotations there are 2 matchings, that means after 2 rotations that means frequency of 2 would be 2, because after 2 rotations there are 2 elements on their correct position. Frequency of 3 should be 0, because after 3 rotations there are 0 matching. As we can see frequency of 3 is 0. Similarly frequency of 5 should be 0, and we can see frequency of 5 is equals to 0. So instead of performing rotation again and again and counting, what you can do for each element, you can simply ask him, okay, after how many rotation you will be on your correct position. For each element you can count this, and then you can count the maximum frequent element. So the element which is having the maximum frequency, just print the frequency of the element. So here 0 and 2 are having the maximum frequency, which is 2, so you can print the maximum frequency, which is 2, and that is the maximum matching you can obtain. So for each element, how you are going to count the maximum the number of rotations it would require to be on its correct position. So we have already seen the formula was j minus position of j plus n. Now j is element j, so 5 will be on its correct position after how many rotations. This would give you that this formula would give you the number of rotations required for an element j to be on its correct position. Now this j here is the final position. When we talked about this formula, we were talking about the identity permutation. That means at position 1 we were having 1, at position 2 we were having 2, at position 3 we were having 3, at position 4 we were having 4, and at position I we were having element I. So now if we are talking about element j, the correct position of it is j, right? So this is the final position, and this is suppose I'm talking about this array. Okay, this is the array, and the array with which we are matching is actually 1 2 3 4 5. So element 1 is supposed to be on position 1, so it is on position 1. Element 5 is supposed to be on position 5, but it is on position 2. So this j represents the final position, this represents the current position. So for 5 current position is 2, while its final position was 5. That is why j minus position of j we were having, because we were talking there about the identity permutation, but here we do not have the identity permutation. So the formula is a little bit changed. So if you are talking about the jth element, for example 5 would be after how many cyclic rotations 5 would be on its correct position. The answer of that is the final position of 5, j is 5 here, final position of 5 is supposed to be 2, right? So 2 minus current position of 5, current position of 5 is 1. So final position is from array A, current position is from array B, because this array would be rotated, so 5 would be coming to here. So of course 2 minus 1 plus 5 modulo 5 would come out to be 1. That means after 1 rotation. So this formula gives you the number of rotation for each element to required to be on its correct position. So final position of jth element minus current position of jth element plus n modulo n. So if I show you the code, and then we can simply count the maximum frequent element. If I show you the code for this, here we have that. Now position would store the position of each element, because it would basically store the final position. So when array AR is coming, so first input is 1, which means element 1 is supposed to go on position 1. Second input is 5, that means element 5 is supposed to be going on position 2, that is the final position, and POS is actually keeping the final position. And this is to count the frequency of each element, so that frequency of this rotation, so that we can get the maximum frequent element, and that would be our result. So we are reading n elements, each time we are reading x, and position of x is equals to I. So when the input is 1, so position of 1 is 1, final position of 5 is 2, final position of 2 is 3, final position of 4 is 4, and final position of 3 is 5, right? So this is basically storing the final position of each element. After that, we'll be given the B array. So in B array, each time I'm reading the element x, which is the final position, current position. When we are reading B array, so I is equals to actually I represents the current position, so current position of element is equals to I. Final position of element you can get from pose array. As explained earlier, pose array stores the final position of any element. So this is the element position, final position of element we can get from pose array. So y is final position, x is current position, so the number of cyclic shift is final position minus current position plus n modulo n. And now at this index in frequency array we are incrementing, and then maximum is initialized with 1, and in the frequency array from 0 to n, in fact we are counting the maximum frequency and then printing the maximum frequency. And this is the problem that you will be solving. So this is how we solve this problem. So this was all for this lecture. If you have any doubt or query, of course you can ask me in the comment section. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.